Hello everybody, my name is Filip Sebek, and together with me is also Simon Monié that will have this presentation on how we test our software on ABB Marine and Ports. And this is quite new, it's a work in progress, and we are hoping to get new ideas or add things to this way of testing. And so when we went into the VeriDevOps, we wanted a couple of properties with our tests because we didn't have a proper test suite. This was something that was just maybe done by the developer, and we would like to have an automatic way to test our software on the crane. And basically, we wanted to have some kind of download the standard code and then build it automatically and then run some kind of regression test to see that it works. Maybe do some safety test on top of that. And then when it has run all the tests, typically during a nightly build, we wanted to generate a report and maybe display it on a screen in the office environment. So stating that, okay, this night we built it and we got 2 errors and so on. So, right. So Simon, maybe you can explain more in detail what we try to do.
Absolutely. So what you see on your screen before you right now is the main tools we are using presently. So we're using Robot Framework, Nexus Repository, and Jenkins. And to the right, you can see the ABB AC500 PLCs that which is our system under test. And I will talk a little bit more about each of these tools in the following slides. Yes. So for Robot Framework, Robot Framework mainly works in 4 layers, where the top layer is the test data layer, which uses a tabular format using their own keywords, which are kind of like built-in functions in Python. You can make your own keywords, or you can use Python scripts in this layer if you want, as an input for the next level, the layer, which is the Robot Framework layer. And it processes the test data and will generate reports and logs in HTML or XML format that is used to display for the viewer, for the tester, or via email, as Philip talked about earlier, or on a screen. I will show you 2 pictures in the next slides what it can look like. The third layer is the test libraries. Here you can either make your own, or you can use other user-made libraries, such as Selenium to test web browsers or things like that. And the bottom layer is the system under test, which is the target. And for us, that's the AC500 PLCs. We also have several other systems, but at the main moment we're testing the PLCs, and then we're going to expand more on the subsystems, like the LPS camera that we've mentioned before. Yeah, next slide, please.
There's a test report. You see it?
No, now I see it. Yes, now I can see it. Yes. So this is one of the test reports. This is just a general view of what it can look like. So what you can see before you is that this is passed. It contains all the important information, such as when it was started, when it was ended. You can sort the tests by tags. For example, if you have smoke tests or unit tests, integration tests, regression tests, you can see how many has passed and how many has failed, etc. And you can also go into a more detailed view, which is the next slide. And this is the test execution log. And from here you can see, now I can't point, but you see where it says set up clear login database. That is a keyword that I mentioned earlier. And the same with the one under that, the user can create an account and log in. So these are keywords or functions made in Robot Framework that contain code on what is to be done, and it can be reused for different purposes. So you can reuse it. And from this you can open them up, like the invalid password one here, which has failed, and then you can go to the status should be, and you can see the traceback of what went wrong. And from this you can also include that it should take a screenshot of what you can see on the screen if you're performing tests. So when it fails, you get back some visual information of what happened, what could be seen on the screen when performing this test, and then you also get the text. So it's good for debugging. And the next tool we use is the Sonotype Nexus repository, which is an open source repository that we mainly use to store our artifacts for releases and snapshots of releases. We can use it to publish and retrieve versioned apps, mainly not used by us today. And it's easily accessible from other environments, and that's a very positive part, since we access this from Subversion and from Jenkins in our automation. Yes, and Jenkins. This is kind of like the main part of our tools. It uses Robot Framework and Sonotype Nexus, and it's an open source continuous integration, continuous delivery, CI/CD automation software tool, which is written in Java. In it, you can implement workflows, mainly called pipelines, and the pipelines are used to automate testing. So in a basic sense, you have a Jenkins master. The Jenkins master has Jenkins agents, which can have like Windows installed or Linux or whatever operating system you want. You can have different dependencies if you need certain Python plugins or Python modules. So you can run tests, and you can designate, I need a Windows agent to run this test, or I want a Unix agent to run this test, and it can then set up the environment on that agent and launch the tests. Yes, you can also use it kind of like a repository version handler if you want as well. And this is a photo from our Jenkins. You can see here to the bottom left, you have build executor status. These are the agents that I was talking about earlier. So it's servers just waiting for Jenkins to tell them to set up the environment and then run tests. In the middle, you can see the pipelines under name. So you see we have AC500 automated tests, AC500 crane standard, and it does not only have to be tests that are run. So like, for example, the AC500 crane standard for us is a collector. It collects from Nexus and then packets this into zip files, and then takes it from the Subversion, I mean, and packs it into zip files and then uploads it as artifacts to our Nexus server. So you can have small and big pipelines. Yeah, next slide. And this is a closer view of a pipeline where you have in the first column, it makes a checkout, then it prepares the build metadata, it builds it, and then archives the artifacts if it's a successful build. And then it will restore the agent's workspace. And this is based on commits, as you can see to the left. There's been a commit that has started this, and then you can also start it from the web page if you want to as well. And this is the current flow of what our regression testing is. If you start from the developer's screen, they will gather information, gather code from the Subversion server, and then they will develop something, maybe change a function or fix a bug or anything. And then they will commit that code back to the Subversion server, which will activate a post-commit hook that contacts Jenkins, which will download artifacts from the Nexus repository to set up the correct environment to test this code. And then Jenkins will fix the environment on an agent, and that agent uses the robot framework. And that robot framework is then connects to a PLC and performs the tests, and then reports back to Jenkins if it has passed or failed. And then Jenkins will then deliver an email to the developer or the developer that's in charge of that pipeline.
Yes. Or I can maybe explain a little bit what kind of test we are doing at the moment. Yes. It's pretty simple. We set up the full environment for the crane, and then we will send an order to the crane in this simulated environment. And a typical order would be like, pick up that container on coordinate XY and move it to another position in XY, because then you need to like identify it, you need to lift it up, you have all the motions, and then you have to call for other functions to find the spot where they should have put it. So even if we're not using like all functions on the crane and all the exceptions handling and so on, we're making just a simple move with a container where we're actually using many parts of the crane functionality, and that's it. We could of course extend it, but that's what we do now. And from this, we will not only just test the crane, we will also test the order system, we will test the diagnostics and so on. So it's like the full complete system, not just some safety part. It's the full crane. Is there something you want to add, Simon?
Yes. That's a very well description of what we're testing. As you said, there's so many small parts that we're already testing with inbuilt signals and events. So what the program, the tests are mainly checking is that do we trigger an error or a warning, and then we report that back by doing this automated robot movement. Yes.
Yeah, and the other day, I think it was yesterday, you were running this test, and then all of a sudden we made a small change, and then we got lots of events and warnings from the diagnostic system stating that we were running too fast. We had like an overspeed in the motion, and there was no overspeed. It was a bug in the code that detected this unintentionally. So it was really helping us not to wait to fix this bug until release date. We can fix it now. And this could normally maybe, I do not know what the source of that bug was, but it could be an indirect change. So the person that made the change, it influenced what triggered the event.
But you can perform the regression testing.
Sorry,
when you introduce change.
Yes.
You can do regression testing, and
yes, this is what we can do directly, but now we do it like on a regular basis, not before we check in something. We could have done that too, but this system is still not mature enough for anyone to use, not yet. But that could also be like applicable. Before you check in something, you could run all the tests and you're not allowed to check in something that will generate all these faults. That's also a possibility. Yeah, Dragos.
So you are running the tests. I don't know if the audience can hear the remote audience, but are you running the test in a simulated environment?
Yeah, the question was if we were running the testing in simulated environment. Yes, we do.
Yes.
So we actually will test also like the LPS system, because when we make the motion, then of course the load will start to swing, and then the LPS has to detect this, and then it will say to the engines to stop in time and even out the swing, for instance. So yes, we simulate as well.
And how do you deal with real-time properties? I mean, if you need to do some moves within 10 seconds or 10 milliseconds, can you test that in the simulated environment?
Yes, we can, because the simulation is running on the same PLC, so there is no issue there. Yeah, but of course you could have a probe effect there, so it's hard to detect things like race conditions and so on if you remove the code. But generally, I would say this is a huge step forward. The only thing we could do before was to actually execute this on a real crane. So now we can do this in the simulated environment instead, and automatically. We don't have to test it and learning how to control the crane. We just press the button and it will perform like downloading, creating the code, run the tests, upload it as a release, and make a report.
An addition there as well, since we want to keep it as much as like a real crane as possible, but still keeping it in-house, we're running this as a hardware in the loop test as well. So we have our different hardware systems in this stage. It's not all of them, but we're expanding it. So we have the XCC, for example, that handles the block map and the ship map and sends the work orders, and then we have the CMS computer, which are hardware that is used on the cranes to test this.
We can do the simulation partial. So all the real systems that we have, we can connect those, and then we can disable the simulation from those. So you could have like a partially real, partially simulated environment. What's possible. So this is a really strong way to work with, because ideal would be to have a real crane, but we don't have that. Yes, yes. But
It works.
It works because, I mean, the system, normally the systems, they are very isolated environments, so it doesn't have too much impact on everything else. So that's why we can do this. If it would be a very complex system where everything interacted with each other, then it would be harder. But if we add sensors and set up in the environment, okay, this sensor is looking in that direction, then it will look the same way all the time, but at least we will test communication, we will test different kinds of race conditions.
Analyze the result of the test. When you mix reality with...
We're not that far. No, we're not that far. We're just glad to make it work at this stage, and then maybe it's a dead end from an analysis point of view, but the alternative, we don't have many alternatives actually, and create good simulations, that's also really hard, how to validate those and so on. So we've seen that all our simulations, they are very modeled. So we need noise, we need things that can go wrong to help us. I have a few more slides here. So we also, on top of that, now we will add safety tests, because we have done tests on our safety code as well, and that's much more mature, I would say. That's also code that we import into the PLC. I described that in the beginning of this project, how we do that. So now we will add these tests in parallel with the big regression test, because this imported code, that can also be controlled by Jenkins and read in the simulations and so on. So it's pretty simple. We have macros, and then we, instead of just importing the code for a certain crane, we can also now import standard safety tests. So this is normally not included in the release, but for the test, we import the test and then we execute them, and then it looks pretty much like this. Here you can see a couple of functions: emergency stop, some bypass mode, prevent start, and so on. And here you can see which test case it has been running and if everything is okay. So we'll get the reports from this. We can make, for instance, a screenshot from Jenkins to see how the result was as a part of the test report. So well done, Simon. You have been working a lot with this for the past year, but now we're getting closer. And we also hope to get some help here from Mikael, that has looked into how to analyze this type of code. And so we hope to get some cooperation there in our lab. And hopefully we can also get some help with all you other guys. So just a conclusion again. We download the standard source codes from SVN. That's one repository, but that's not where we'll release it. That's where we just work on our daily. Then the script will build. It will run the regression test, run this very simple test, like take a container and put it somewhere else. But from that, we test lots of functions. And running this type of test, it takes several minutes. So it's not just like, but it takes some time. These safety tests that I showed here, they take actually several hours to run. And then after that, we will run the safety functions and module test of the safety code. And then when that's done, we upload the release of the standard code, send these reports to users. And finally, we might get this screen where we'll display the results of the nightly build. That was basically it. More questions?
I don't know if we have time for questions. Just very short question. So this testing that